way too many people to acknowledge. I can't put them all even on 2 slides, but there are the Centers for Mendelian Genomics, the Centers for Common Disease Genomics, the centers. Especially thank our coordinating center and Sequence, and also members of our external. With that, I'll end and open up for questions for either me or Chris. Right. So, I think
Chris covered it pretty well. I think one of the things that the external panel is really looking forward to is we're about halfway through, so the data is just getting there, particularly for the CCGGs. And so a lot of the analysis and the results of that aren't quite there because the data is just getting there. The Freeze 2 is just coming, right? I mean that's
yeah. Freeze 2 is next month.
Yeah, next month. So and there'll be a lot more that they can do with that, and particularly with like the analysis centers. They're gearing up with ideas, developing methods that they'll be able to apply that. So I think in general, you've seen the recommendations. We certainly feel reasonably good about how this is going.
So when you count the significance, and that's based, I assume, on p-values, Peyronie corrected p-values. What are the effect size?
Yeah, so that was on the slide, and I could go back to it. And again, it's not my slide, so I can only comment so much on the details, but I'll go back. So inflammatory bowel disease, these are moderate effect sizes, so threefold, same for cardiovascular disease, maybe larger effect for schizophrenia, and then huge for autism. I wouldn't read too much into the details of the slide. Right.
The reason I'm asking is because if you have, in some of these, I assume that you already have a huge sample size, and you only had a few go over the significance threshold, which could be lowered if you went. By adding more and more samples, you might get something significant, but now the effect size must be very, very small. And the question is, does it even matter at this point?
Yeah, so that's a whole question that was anticipated, maybe not fully anticipated at the beginning of the program. And that was one of the reasons one of the several reasons to try with a select number of diseases to push as far as we could push. We were told by one council member at the time, you'll probably have to go farther into the realm of diminishing returns than you wanted to in order to understand really where you were, but where you are. And we did have maybe the naive idea at the outset that we could bring enough sequencing power to this to actually be comprehensive about a few diseases. But things have gotten, the picture of genomic architecture disease, I think, has gotten quite a bit more complicated since then. But this is a very important question, is what is the point of diminishing returns? When do you know you've hit it? And what's the system? Jonathan?
Maybe I could address that a little bit. There's a difference between the effect size of the individual variant, which could be, it could be extremely rare, but that variant may have an extremely large effect. The question is population attributable risk. How much does it mean to the population as a whole? And that's where you start getting into how far down, do you want to go in terms of diminishing returns at the population level? Certainly for the individual or the family that has that rare variant, it's very, 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 very important. And it might open up new biology. You don't know. But, that's a balance that I think everybody is struggling with a little bit.
Well, I will say,
my bias would be that that we may already be at that point. But I think it also depends on dividing it up into this dichotomy of whether we're doing this to explain disease risk through specific findings, or whether we're doing it to get to leads, for biology. If we're doing it for risk, I think that one of the most, and you highlighted a bit here, but I thought the study from Zach Katharisian, I think is still on bioRxiv, and I think that's one of the most exciting developments of the last couple of years. And I think we should be paying a lot more attention to it. Maybe you guys already are, but I feel like it should be kind of permeating through all of the genomic medicine aspects of this institute as quickly as possible, what the implications of that are, right? Because all of the genomic medicine folks tend to really be focused on the rare variant specific genes, and if this really is that we can predict, an equivalent risk for a much larger fraction, that has pretty big implications.
Yeah, so essentially the same thing was said by our ESP during the meeting in April.
I guess another comment is that following up on Jay's comment, if what you're interested in is in lead, then Ferroni corrected at whatever it is, 0.05 or 0.01 level is incredibly conservative, and you could definitely make that instead into a FDR of 0.05, and then your sample sizes come way, way, way down. If what you want are leads, just comments. Do millions and millions of dollars.
So these are discussions that happen almost weekly. Certainly when we're having joint meetings, those discussions come up. Where should we go with it? If you loosen things up and you do more of the polygenic risk score kinds of things, can you where can you go? So these are ongoing discussions and debates. So it's a good point. This is coming at it as a bit of an aficionado and not, knowing the details of this area super well, but just looking at it from the outside, it seems like focusing resources on getting polygenic risk scores for non-white populations would be a super use of money in the near term, if that's at all a possibility with the cohorts that are available.
Yeah, so Jay, we've just started to think about this again since April, since we saw that presented, and some of that has to do with how much of a shift it requires in analysis and also in data production, and we just haven't thought through that.
So I don't know if you've done this calculation, but could you figure out, in terms of identifying new leads or new targets, cost per target that you identify in terms of either the CMG or with the common variants? And if you did use the CMGs for getting at some of the common diseases, are those phenotypes represented in the CMGs?
So the easy one first, I guess. For the CMGs, it's about 30 exomes that we sequence for each thing that gets counted as a discovery. We said there's a little nuance to what a discovery is. So there, it's relatively low. And whether it's representative on phenotypes, that's something that we tend to find out at the end.
Right. And my inclination is to resist doing that too soon for the complex disease, because right now the cost per is going to be astronomical. Right. Well,
is autism a Mendelian disorder that's very heterogeneous or a complex disorder?
Can I just answer yes?
Well, the question goes to what do we learn in going forward and selecting other disorders to